This video reviews statistical graphs. Now before we start, we have to look at types of data because that will affect what kind of graph we can have. So data can be divided into categorical or qualitative data, which involves characteristics or words, or numerical data, which is quantitative, and that can be assigned a numerical value. So when we look at our categorical or qualitative data, it can be split into nominal or ordinal. Now nominal categories have no order, so we could have eye colour, brown, green, blue, or we could have gender, male, female, or we could have types of cereal that we eat. All of those would be classified as nominal variables. The other type of qualitative or categorical data is ordinal. Now those categories can be ordered, so we might have low, medium, high, or where we go from strongly disagree up to strongly agree on a scale. When we look at numerical or quantitative data, it can be split into two types, and the key point is, can it be measured or can it be counted? If it can be counted, then it's going to be discrete. So we've got exact values, most often integers, example, number of children in a family. In contrast to that, can it be measured? If it can, then it's going to be continuous data. So any value within certain limits, example, height, temperature, time taken. So the thing to think about here is you can have decimal answers. So it's continuous data. Everything in between is a possibility. So let's look at frequency histograms versus column bar graphs. Now visual displays show patterns that exist in a mass of data. Frequency histograms are for continuous numerical data, our quantitative data. It can also be for group discrete data, but most often it's for continuous data. So with a frequency histogram, our columns touch. Now column graphs are for discrete variables. The columns do not touch. We have to have gaps in between them. Histograms and column bar graphs show and compare the frequency or relative frequency of data values in each category, and they consist of rectangular columns of equal width, and the height tells us what the frequency is, how much each thing occurred. So a column bar graph, discrete data, gaps are left between each column. Histogram, continuous data, no gaps are left between the columns, and the column graph is now called a histogram. And normally with a histogram we'll have a gap at the beginning, which is not shown in that graph. We could also use dot plots and stem and leaf plots. Now dot plots and stem and leaf plots can also be used for a single set of categorical or discrete data. So hours spent on homework per week, you can see a dot plot here. So for example, we can see that 5 students spent 1 hour per week on homework, whereas one student spent 9 hours per week on homework. So each dot represents a person. With our stem and leaf plot, we need to have a key so we know what it's showing. So here we're looking at age. So if I looked at this figure here, the 3 with a 2, that means 32 years old. So if we looked at this 5 here, we have 5 people who are in the 50s. Okay, so 52, 56, 57, 57 and 58. So a stem and leaf plot gives us the shape of our distribution as well, because as you can see here, we can see that shape. So there's quite a lot of people that are in single digits here, not that many in the older categories. So the majority of people, if you looked at this distribution, are in the 30s or younger. Now the shape of the distribution, moving on from that, we can look at symmetrical, where if you were to draw a line graph, it's approximately symmetrical here. It's not exactly, but we have equals amount on either side of that middle. Positively skewed, we have a tail happening on the positive end. So we don't have much data or much high data. Most of our data is low. So if we think about that stem and leaf plot, that would be considered positively skewed. Okay, so most of our data is down the negative end, but we have this tail on our positive end, which is why it's called positively skewed. Negatively skewed has the tail on the negative end. Okay, so you've got some low figures, but the majority are up the top. Okay, and this is important because it's going to affect our data if we find statistics or calculate statistics. So let's look at an example. The data set below is the test scores out of 100 for a maths test for, that should be 48 students. Okay, so we have a whole heap of data here that's showing test results for 48 students. It says construct a tally and frequency table for this data using class interval 0 upwards, 10 upwards, 20 upwards, etc. So we're going to go, because it's discrete data, 0 to 9, 10 to 19, 20 to 29, etc. Construct a frequency histogram. I keep saying histogram. State the percentage of the students who scored 80 or more for the test. State the percentage of students who scored less than 50 for the test. Copy and complete the following. More students had a test score in the interval than in any other interval. Construct a stem and leaf plot for the data and use your stem and leaf plot to calculate the median. So we need to start by putting our data into a table. So I recommend when you cross a piece off, so 56 is going to go there. So cross it off as you tally it. So 29 goes there, 78 there, etc. So once you've done it, you tally, put in your frequency. So that's how many you've found in each one. Add up all your numbers and you should get 48 because you had 40 people. Now to do the percentage frequency, that's going to be our frequency divided by our total frequency. So for 0 it's going to be 0%, it's pretty straightforward. This one's going to be 1 over 48 times by 100. So you're converting those frequencies into percentages. So do those on your calculators and recommend rounding to the nearest percentage. And if you add them up, now we have rounded, but we should still get 100%, which we do. Okay, so now to create the frequency table, our histogram, we just did the frequency table. Frequency will go on our y-axis, and then we're going to have our class interval on our x-axis, and when we're doing a histogram and it's group data, we label the ends. Okay, if you don't have group data, then you label the middles, but when you have group data, you label the outside. That's a common mistake. People don't label their x-axis correctly, so make sure you take note of that. Okay, so this is our class interval, which is our mark. And we should also do a heading, which is maths test scores. And we can go out of 100. Okay, so from 10 to 20 we had no one. From 20 to 30 we had one. Helps if I put a scale on my y-axis. 2, 4, 6, 8, 10, 12. So we go up to 1, and it's 1 for 30 to 40 as well. Then we've got 3 and 10. 12, 8, 10, and 3. Okay, so if you were talking about the distribution of this, you could say we've got a few scores, some low scores there, and they're on the negative end, so we would say it's negatively skewed. Okay, so let's answer the questions that we were asked. So we've constructed a frequency histogram. It said state the percentage of students who scored 80 or more for the test. So 80 or more would be these two here. So that would be 27%. So part C, 27% scored 80 or more. Then we had state the percentage of students who scored less than 50. So less than 50 would be those there. So 6, 7, 8, 9, 10%. Okay, so there's those questions answered. Then it said copy and complete the following. More students had a test score in the interval whatever than any other interval. So our largest frequency is the 60 to 70. Okay, so E would be 60 upwards. And that's our mode or our modal group. Okay, so now we have to conduct a stem and leaf plot for the data, and we know that we had people, well, we didn't have anyone in the 0, but we'll still put 0. So we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have to do individual data. So 56 would go there. 29 would go there. 78. And try and line up your columns of numbers so you can get that shape of the distribution. Okay, so you keep going. Okay, so that's done, but a stem and leaf plot always has to be in order. So once you complete that first one, you then need to order your data. So go through and put the data in order. Again, I recommend crossing off data as you do it so you'll know if you accidentally miss something. Okay, so that's the stem and leaf plot finished, and I should put marks for maths out of 100. So I've got a title, and then the question wanted us to look at the data and comment on it. So use your stem and leaf plot to it just said to calculate the median. So we've got 48 pieces of data. So if we go, we've got 48. So that's 2 lots of 24, which means I need to look at the 24th and the 25th scores. Okay, so now that's why our data has to be in order. If we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So 24 is 67 and 25 is 68. So I've run out of room, so I'm just going to write median here is going to be equal to 67 plus 68 divided by 2, which is 67.5 marks is our median mark. And we could also comment on our distribution here and see that we do have a slight tail down the negative end. So complete exercise 9A on page 564 of your textbook.